Okay, Pre-Calc, here's part 2 of the 5.2 video series. So we were talking about finding all 6 trig ratios of some angle given to you. So I gave you guys this angle kind of arbitrarily, didn't really matter. Find all 6 trig ratios. Well, in the first example, you guys had all 3 sides. So the only thing we're adding to it is finding the third side as a reduced radical expression. So we're going back to the first day where we talked about the Pythagorean theorem, a squared plus b squared equals c squared. Remember, the a and the b are the 2 legs, so a squared plus b squared equals c squared. Here's the equation we can use to solve for this unknown side right here. So 1 plus b squared is equal to 64. And then we can subtract 1 from both sides on this. So b squared is equal to 63. Square root both sides. Remember, we're disregarding the negatives when you square root both sides because we're talking about the length, the side of a right triangle, and we're not really dealing with negatives in that scenario. So what we want to do is simplify root 63. We talked about how you could use a factor tree to just break it down to its simplest form. So 21 goes in there 3 times, and 7 goes into 21 3 times. So when you see this, you're thinking to yourself, every pair of factors can break out of the square root, right? Because the square root of 9, right, is 3. So there's a 3 on the outside. And then the 7's the only other prime number that should be left over underneath the square root. So it's 3 root 7. So we're going to put 3 root 7 in place of our unknown side right here. All right, great. So now what we need to do is determine the 6 trig ratios. So to give us some room, I'm going to erase this. And remember, we had sine of theta, which is the opposite over the hypotenuse, the cosine of theta, which is the adjacent side over the hypotenuse, and then we have tangent of theta, which is the opposite side over the adjacent side. So I'll determine these 3 first. So in sines in theta's world, the opposite side is 1, and the hypotenuse is going to be 8. So sine of theta is 1/8. Easy enough. In theta's world, the cosine, the adjacent side is going to be, remember, it's adjacent leg, so 3 root 7 for adjacent leg divided by the hypotenuse of 8. That's as simple as it gets. Tangent would be opposite theta is 1 divided by adjacent to theta, 3 root 7. Now here's where we have to stop and say, isn't there something where we have to rationalize the denominator, make it so that the denominator is a whole integer, not a root? And yes, there's a strategy for that. If we multiply the top and bottom of this fraction by the root that we see, namely root 7 in this case, root 7 times root 7 is 7. And 7 times 3 is going to be 21. So now we've successfully made the denominator of this fraction an integer, or like a whole number. 1 times root 7 is just root 7. And this is technically the simplified version of what tangent's going to be. I want you guys to do these on your homework. Make sure that it's rationalized like this. By the way, this is called the process of rationalization, making the denominator of the fraction an integer value. Woohoo, we got the first 3. Now, recall that cosecant is just the flip of sine. I know, it's kind of hard to remember because you'd think cosine, the flip would be cosecant. But I think we're dealing with Greek roots here that are a bit iffy when we talk mathematics, so I'm not going to dig into that, but just know that these words actually mean something that can connect them to their predecessor type situations. Okay, so cosecant is the opposite or the reciprocal of sine. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. So then we can just go back to our original fraction, 8 over 1. Well, that's just 8. 8 over 3 root 7 would be secant, which requires us to rationalize, multiply top and bottom by, in this case, root 7. So that's going to be 8 root 7 over 7 times 3, 21. There's no simplification with 8 and 21. And then cotangents. You know what? Instead of flipping this, I'm going to go back and flip the original opposite over adjacent. Here's why. If I were to flip this, I'd get 21 over root 7, requiring me to do this rationalization process. But 3 root 7 over 1, that doesn't need to be rationalized. In fact, anything divided by 1 is just itself. So keep that in mind, that you can save yourself a lot of time and potential error reduction, right? Because the more steps you put in there, the higher probability you're going to make a mistake. And just say, okay, opposite over adjacent flipped. Maybe it was easier to go back to the original. Anyway, so this is number 1. These are the 6 trig functions. Just make sure you know how to find the unknown side in simplest radical forms. I don't want to see any decimals in your final answers when we're finding the 6 trigonometric ratios of theta. No decimals. Okay. Now, that's not the only way I can pose a task. What if I said find all 6 trig ratios of theta, but instead of giving you a right triangle, I just gave you, hey, the cotangent of theta is equal to 3. Can you find out how to get all 6 trigs? Well, here's the strategy that I think is the easiest to think of. What if we drew a right triangle using the fact that the cotangent is equal to the adjacent leg divided by the opposite leg, and the fact that 3 can be written as a ratio 3 over 1. So here you go. Let's put theta, let's just make a triangle like this. Let's call theta this corner right here. Adjacent 3 over opposite 1. Well, now we have something that looks just like our first example, or I guess our second example for this video series. Yeah. Now we just do exactly what we did before. Our unknown side is the hypotenuse, so a squared plus b squared equals, the unknown in this case is c squared, a squared is 3 squared, b squared is 1 squared, and then we solve for c. So it's going to be 9 plus 1 equals c squared, 10 equals c squared, root 10 is c. Okay, so then at this point, you guys would say sine of theta, cosine of theta, tangent of theta, opposite over hypotenuse, adjacent leg over hypotenuse, opposite over adjacent. You know, if you're kind of, I don't know, not 100% on the trig, it might be a good idea to just keep writing these little ratios to remind yourself what you're actually computing. But if you feel pretty confident, you don't need to put this every single time. In theta's world, 1 is opposite theta. And then your hypotenuse is root 10. Multiply top and bottom by root 10 to get rid of that root on the bottom. So we're rooting out the bottom, and you get root 10 over 10. And there it is. Cosine would be 3 over root 10, which if you you see what happened with above? You can kind of just skip the step of even writing down times root 10 over root 10. You can just skip right to saying, hey, this is going to be 3 root 10 over 10. And you guys might need some more practice before you can go directly to that step. But yeah, just saying, be looking for those patterns that make computation less burdensome. And then opposite over adjacent would be 1/3. You know what, though? We should have been able to say that right off the bat because we had 3 over 1 for cotangent. Tangent would be 1 over 3. All right, and then lastly, I'll just put these underneath here. Cosecant of theta is the flip of opposite over hypotenuse, so I'm going to go right to the original. Root 10 over 1 is just root 10. Secant would be the flip of cosine, so it's going to be root 10 over 3. And then cotangent, you know, you already have it, so I guess I don't need to really rewrite it. There's my last one. Okay, I think this is a good stopping point for this video too. There's one more section of problems that probably require me to do a little digging with you on a video, but part 3 is where we'll leave that.